Welcome to this explainer. If you look at a calendar, July 10th just seems like, well, an ordinary summer day. But it's actually, and I mean this literally, one of the absolute most golden dates in the entire history of mathematics. Today, we're going to dive right in and uncover exactly why that is. 1682, 1824, and 2007. On this one specific date, spanning totally different centuries and countries, some truly brilliant minds were either born or passed away. And these are the exact people who, quite secretly, built the digital world we all live in today. Let's actually meet them, one by one. First off, how does a computer know the exact smooth curve to draw when it's mapping out a flight path? Have you ever actually wondered how software can calculate a completely perfect trajectory out of just a few scattered, random data points? Well, for the answer to that, we've got to rewind the clock all the way back to July 10th, 1682, to meet an incredibly brilliant English mathematician named Roger Cotes. Cotes developed numerical methods like interpolation. Now, in plain English, interpolation is a method used to create new estimated data points between known ones to form a smooth curve. It is the literal, exact mathematical foundation our computers use right now to seamlessly connect the dots. Every time a computer connects two dots smoothly, it is using the math of Roger Cotes. Actually, Isaac Newton himself famously said of Cotes, if he had lived, we might have known something. It's kind of a haunting thought, right? But it just proves how totally fundamental his curves are. They literally run our software today. Okay, we are still on July 10th, but let's jump ahead a bit to 1878. And here, we're looking at a completely different kind of challenge. Picture this, a modern submarine plunging into freezing, pitch-black ocean waters. To avoid a catastrophic crash down there, it has to map the ocean floor using completely invisible sound waves. How do they see these hidden obstacles? The math that makes that sight possible actually comes from an American mathematician born on July 10, 1878. His name was Oliver Kellogg. During the incredibly high-stakes pressure of World War I, Kellogg used something called potential theory, which maps forces like gravity and sound passing through spaces to design mathematical devices that could detect submarines. His crucial work literally laid the exact groundwork for the modern sonar technology we rely on today. So the invisible waves that protect ships today are guided by Kellogg's equations. His math allowed sailors to literally see the invisible, proving that potential theory isn't just some dusty textbook concept. It's a real-life protective shield. Still the exact same date, but flashing way forward now to 2007. We're crossing over to France to meet another truly incredible mind. The next time you're playing your favorite video game and you launch a digital car off a massive ramp, pay close attention to the gravity. Making those physics look incredibly realistic takes some serious, heavy-duty computational power. How do they know what motion should look like in a 3D world? Well, those digital physics engines owe pretty much everything to a brilliant French World War II survivor named Paulette Libermann, who passed away on July 10, 2007. She made these absolutely massive contributions to differential geometry. That's the study of curved spaces and shapes. And she provided the exact mathematical formulas the computers absolutely need to accurately simulate curved shapes, motion, and physical forces in 3D space. Every single realistic jump or crash in a video game owes a huge debt to differential geometry. It is just wild to think about, really, that her highly abstract, super complex theories are exactly what makes our digital entertainment feel so visceral and totally real today. One single date. So many amazing stories, right? As we wind down to the final piece of our puzzle, let's jump back in time one last time to July 10th, 1824 to meet our final mathematical architect. Think about the gaming controller right there in your hands, taking a physical flick of your thumb and instantly translating it into an exact digital direction on a screen. That is a massive mathematical hurdle. And that hurdle was actually cleared by a man born on July 10, 1824. His name was Wawrzyniec Żmurko. He was an early pioneer of vector calculus in mathematical instruments. Vector calculus is the study of direction and magnitude used to track movement. By mapping that out, he created the exact math we use right now to track physical motion in our everyday technology. The math of direction turns physical movement into pure digital magic. By doing just that, his 19th century theories laid the absolute rock-solid foundation for our 21st century interactive hardware.
Okay, let's wrap this all up and see how everything we just talked about builds together perfectly on this one single calendar day.
What connected them all? Well, every single person we met in this explainer, from completely different centuries and countries, they all essentially asked the same fundamental question. What is the pattern hiding inside the chaos? And because their math successfully bridged the physical and digital worlds, our lives today have everything from 3D video games to submarines to smooth GPS routing. So, what hidden patterns in our world will the next July 10th mathematician discover? As you look around at all the crazy technology surrounding you today, really ask yourself, what other invisible math is just waiting out there to be uncovered next?